Good evening, class. We finished the last session with section 6.6, phase shift sinusoidal curve. So the synopsis of what we have covered. The first section, basics of trigonometry, was covered. The second section, unit circle and a circle in general, and the way we define x and y as sine and cosine, and the relationship among the rest would be that they're basically reciprocals, with the exception of tangent, which is the ratio of sine to cosine. Important identities known as fundamental identities, Pythagorean theorem, even and odd properties. Graphs of sine and cosine was discussed. And one easy way to handle it would be to come up with 4 arcs, which means calculating the period, cut into 4 equal pieces, and come up with sub-intervals. The end points of each interval needs to be evaluated, giving us 5 pairs. Notice there are 4 sub-intervals and 5 pairs, and that would be the graph. The rest of the functions, we should have an idea how they are, what is their domain and range. It has got to do with understanding that a fractional format, the denominator cannot be 0. So for example, looking at y equals tan x, it's the ratio of sine to cosine. Cosine can't be 0. So you can find the domain, you can find vertical asymptotes. All of them have vertical asymptotes except sine and cosine. All of them have discontinuity except sine and cosine. Okay, class? And as long as we know the ratio, we should be able to come up with just about everything. Just to give you an idea, when you're looking at tangent, cosine is 0 at odd multiples of pi over 2. 2n plus 1 means an odd, where n is an integer. N, sometimes you may see 2k plus 1, okay, class? Nk represents an integer, okay? So 2n plus 1 represents an odd number, whereas 2n represents an even number, multiplied by pi over 2, and that's where sine is 0. So those are the points where tangent does not exist. Those are excluded from the domain. So in short, x is every point except those. And x equals those numbers represent vertical asymptotes. As long as we can put 1 common cycle, then continue indefinitely. So I mentioned last time, you can think of y equals x cubed as far as the rough shape for tangent. Okay? Cotangent is almost y equals negative x. It has been shifted to the right, and both of them, they go with the period of pi. In the case of the tangent, from negative pi over 2 to pi over 2 is a complete cycle. In the case of a cotangent, from 0 to pi. For secant, basically we ignore him. For cosecant, we graph sine. For secant, we graph cosine, we flip them over. This is the synopsis of the graph. Now, what happens when we have a shift? Okay, so basically, depending upon how we write that, assuming a, omega, and phi are positive, then phi negative means there's a phase shift to the left, and if it's positive, to the right. So this was explaining how we do that, and I went through a simple example. The very first thing we did here, we found the period, okay, the amplitude, and the period also we find the phase shift, and the period, which is pi over 2, tells us if there was no phase shift, we would go from 0 to pi over 2. Because of the phase shift of pi over 4, that total interval of 0 to pi over 2 has to be shifted by amount of pi over 4, okay? And then the period is cut into 4 equal pieces, and that gives us 4 subintervals and 5 pairs. We did the same thing in this example, okay? T ends up being pi, so normally we should go from 0 to pi. However, because of the phase shift pi over 2, we move it to the right and we add pi over 2 to both ends. There's a new interval that has to be cut into 4 equal intervals. We find 5 points we have the graph. I believe this is the last one we did. Am I correct, class? We didn't do number 3, did we?
I don't think so. I have 2 here.
Okay. All right. So why don't we go to the next question, and let me set this up such that, let me just get rid of the floating slideshow, and we go to the next one and we do the math. All right. Here's the next example. Okay, class. So we may not have the animation in a proper order. That's fine. Let's start with what we can see obviously. The amplitude is clearly 2. We have to factor out the 4 and write it in this format, because when we do that, we can calculate the period 2 pi over omega, which is 2 pi over 4. And also we see the shift of 3 pi over 4. So amplitude that's the amplitude, okay? 2 pi divided by omega, which is 4, gives us pi over 2. So we are supposed to have an interval of 0 to pi over 2. However, what is the phase shift? If you look at the brackets, inside we have 4 times x minus 3 pi over 4, which results in 3 pi over 4 as the phase shift. So this interval, this entire interval has to be shifted to the right by 3 pi over 4. So we are adding 3 pi over 4 to both ends, namely 0 plus 3 pi over 4, pi over 2 plus 3 pi over 4. Now, what is the period? The period is pi over 2. We divide it into 4 equal parts, so we get pi over 8. So the interval has to be cut into 4 equal parts. How do we do that? You look at the left end point, which is 3 pi over 4, everybody. I want to make sure we understand. I'm repeating what we did last night. This is the first one. Just add pi over 8. So that becomes one interval. And then another pi over 8. Another one, and the last one. And that gives you the 4 sub-intervals. You evaluate the function at the endpoints. So the endpoints are given in green. Again, 3 pi over 4 is the first one. You add pi over 8. You get to 7 pi over 8. 7 pi over 8, you add pi over 8. So on and so forth. And these are the pairs. I want to make sure we understand how this thing works by just looking at one simple example, okay? If you look at the first pair, I want to show you how you arrive at it. All you have to do, put 3 pi over 4 into the original function. There you put it into the one in red or purple, if you will, in the beginning, or in blue makes no difference, all right? So, for example, if you put this right here, I hope you notice what happens. 4 times 3 pi over 4 is 3 pi minus 3 pi becomes 0. Cosine of 0 is 1 times 2 is 2 minus 1 is 1. So this is how you get the first pair. You can put 7 pi over 8 and calculate it and the rest of it. All you have to do, plot 5 pairs, class. 5 pairs. These are the 5 pairs. Okay. And this is just the way it is without paying attention to the negative one, as I mentioned it last time. Now with the negative one, notice what happens, class. You shift it down by 1. So what you see as 3 power 4 comma 2 so on and so forth has been shifted down. Or you can go right from here to this one. It is absolutely your choice. So there are 2 methods, and I discussed that last time, so I'm going to go over both methods one more time. If you look at the bottom 5 pairs, all you have to do, plot 5 pairs and then continue indefinitely on both sides. Okay, class? The other thing is that you ignore this negative one, everybody. You ignore the negative one, and you get this top graph. And then you shift the whole thing down by 1. Okay, I have discussed that with you last time. I hope you've had a chance to go over the previous 2 examples, so it should make it reasonably nice and easy. All right, the next topic in this section, the next topic. So again, plotting points, 5 key points, makes it nice and easy. Okay, you gotta mute your audio and video. Okay, class, I can mute that.
Sorry, Professor.
Sure. All right. Now, these are the steps for fitting a sine function. By the way, when we want to build a sinusoidal function, really doesn't matter if we make it into a sine or cosine. The general notion is that we make it into a sine. So these are the steps, and I will explain those steps with a simple example, but I want to make some sense out of this so you get the idea of why this is the case. The amplitude is the largest minus the smallest divided by 2. So what I want to do, I want to graph a basic sine function to refresh your memory how it looks like. So if you look at the graph of a function, okay, y equals sine x. Remember what's happening here, okay? Starts with 0, 0, gets to its maximum value 1/4 of the way, right class? All the way to the end, it becomes also 0. We're talking about a basic sine graph, okay? Half of the way gets to 0, okay? 3/2 of the way gets to its minimum value. Is everybody clear? Now notice for a basic sine graph, okay? The maximum occurs at pi over 2 comma 1, and the minimum occurs at negative pi over 2. I'm sorry, let's say 3 pi over 2, my apologies. 3 pi over 2. Maybe I use a different color. It might show it better for this. Let me just grab a different color. So it happens that what? 3 pi over 2 comma negative. Now, everybody knows the amplitude is 1, right? Again, we are looking at the basic one class. The amplitude is 1. But look at the formula. It says the largest value. So in this case, the largest is 1 minus the smallest is negative 1. And they add up to 2. Divided by 2 is 1. So this is the reason. Why are they doing that? So what if this is not a basic sine function? It has been shifted up or down, left or right. It has been stretched. Are you with me? For the sake of argument, let's say it's been stretched and a is number 3. Now you have pi over 2 and 3, and 3 pi over 2 negative 3. So you can say the max minus the mean divided by 2. Okay. What about the vertical shift? Imagine the sine function has been shifted up or down. Do you see right now there is no shift? So what is the largest value? 1. What is the smallest value? Negative 1. So they add up to 0. There is no vertical shift. So you end up with 0. Okay. However, if you add them up and you get to any other number, that means there is a vertical shift. Okay. In essence, I'm justifying why this is the case. The synopsis is given at the top right, but I want you to see why in case. Okay. Determining the omega, since the period, remember, t is 2 pi over omega. Everybody remembers that? Okay. So omega must be 2 pi divided by t. As long as you have the period, okay, you can find omega, which is 2 pi divided by t. And by the way, how do you find the period? You look at where it is supposed to start with 0, 0, the first 0, 0, 0, and then the second one, the y coordinate is 0, the third one, the y coordinate is 0. The difference between the third and the first is the period. Or if you look at the distance between the peak, the max, and the mean, if you multiply that by 2, that becomes the period. I hope everybody understands what I'm saying here. All right. Now, the horizontal shift can be found in the following manner. Remember how we arrive at pi over 2, 1, right? The maximum occurs 1/4 of the way. Remember, 2 pi is the period. You divide it by 4, you get pi over 2. So if there is no shift whatsoever, it is supposed to happen 1/4 of the period. Okay. So you look at 1/4 of the period, okay, and you subtract that from where you see the peak. That has been the shift. What do we mean by that? And again, this is maybe, not that easy to see, but let's just look at the examples to make some sense out of this. So here's an example. It says Let's make up an equation for a sine function such that the absolute value is 3, absolute value of A, the amplitude is 3, the period is 3 pi, and phi over omega, okay, equals negative 1/3. Okay. We look at the formula. The formula is given at the top, okay? A sine, the second one, A sine omega times x minus phi over omega plus b. So we want to see what we can do here. And so we start writing the formulas, okay? T equals 2 pi over omega. T equals 2 pi over omega, okay? Or omega equals 2 pi over t, and it becomes 2/3. We are looking at this formula, everybody. You may not remember omega is 2 pi over t, and that's fine, but you should know t is 2 pi over omega. By omega, we mean the coefficient of x. Okay? The amplitude is 3. We put it in. We have A, we put it in. We found omega, which is 2/3. We have phi over omega. I'm looking at this equation, everybody. Okay? Practically, we're done. But we can multiply the 2/3 by the parentheses. As far as I'm concerned, for the sake of graph, we really need this if we are interested in graphing, not the last. But if we want to put it in that form because they have asked to put it in that form, then you have to multiply. The other thing I want to add, and that's extremely important, the way you write this in some text, they use different, lettering. So I'm going to write one example that I've seen. For example, you might see y equals a sine b times x minus c plus d. Why am I writing this for you? Because I don't want you to be under the assumption that this is a different, equation. No, they are identical. If different lettering is used, so be it. Okay. If, for example, this one is used, that's important to understand that the amplitude hasn't changed, but t is now 2 pi over b. Are you with me? So it just depends how they write it. So I don't want you to get confused when it comes to that. All right, we're going to go to the next example, another application, which is the last one I'm going to do for this section. We are given some information, okay, about the average temperature on a monthly basis. So we want to draw a scatter plot and find a sinusoidal function of the form that fits the monthly temperature data for this case. And so you can do the scatter plot. I wouldn't worry about that. I guess everybody can do that. If you do the scatter plot, it looks something like this. Okay, class? So we have month 1 here. January, month 2, February, all the way to month 12, December, And so we want to see, and by the way, when you do the scatter plot, it gives you an idea whether it is cyclical, it looks like a sinusoidal function or not. I want you to know that. And if it doesn't, then it doesn't fit in there. But if it looks similar, we can fit it into a sinusoidal function. So we are going to follow what we just discussed. So in order to come up with that, we need A, okay? We need omega, we need B, we need a lot of stuff. So let's see how we find them. So let's start with the A. So according to this, we have to look for the maximum temperature and the minimum temperature, okay? For the sake of argument, class, so you see how that, I'm looking at, I want to use this one. So can anybody look at the second column and give me an idea? What is the maximum temperature you can find on this column?
Looks like 75.4.
This is the largest. That makes sense to everybody?
Yeah.
Smallest?
The first one,
28.1.
January 1st. Yeah.
Thank you so much. We plug it in. Max minus mean divided by 2. Okay? So we got the A. Now, number 2 is just as easy. The same thing, put a plus sign in between, right? Max plus mean divided by 2. So it's just, we already have the numbers. This time we add them up. We divide by 2. That is the vertical shift. Okay. Now we are looking at average monthly temperature. Agreed? So that means it repeats itself every 12 months. So T is 2 pi over omega. That means the period is 12 months. It repeats every 12 months. And omega, which is 2 pi over T, becomes pi over 6. Is everybody following this so far?
Yes.
Okay, good. So we're almost done. We just want to see the shift, okay? In other words, we are trying to use the second equation, y equals a sine omega. So we are, let me use a different color here. So let me use a red marker here. This is the formula we want to use, class, okay? All right, so we got most everything. And so we need to figure out what is the shift. And to get to the shift, let's discuss what happens here. The maximum of the T is 12, everybody knows that, right? And Y, 12 months, right? Every 12 months things repeat, right? Okay, so that's okay with everybody. So tell me, if T equals 12, remember for a basic sine, we said the maximum occurs when 1/4 of the way. Everybody remembers that? When we cut the period into 4 equal parts, okay? The maximum for a basic sine function happens at pi over 2. That means t divided by 4. Therefore, let's assume there is no shift. If there is no shift, the maximum should occur at 12 divided by 4, which is month of 3. Do you agree with that, everybody?
Yes.
Good. But the maximum occurs in the month of what? 7, doesn't it? So instead of month 3, it happens in month 7. So the difference is the shift. So t is equal to 12. Divided by 4 is number 3. Normally, the x coordinate that the maximum occurs should be at number 3, but happens at month 7 instead of month of 3. So what is the shift? 4. Let's put all of them together. Here's the equation. So, is everybody following that? If we plug in the number of months instead of x, we get a rough answer on the right column, class. So again, you can always calculate, see what happens. For example, if you replace the x with 1, you should get a number close to 28.1. Are you going to get 28.1? Probably not. But you're going to get something close. Are we following that? If you plug in number 2, you should get something close to 32.1. So on and so forth. Any questions? We want to go to the next section. All right, class. So we covered chapter 6. And so we're going to go to chapter 7. In this section, we are going to look at inverse trigonometric functions. We will cover trigonometric equations, identities, sum and difference formulas, double angle, and half angle formulas. There are a lot of formulas here, class, okay, that we are going to cover. I want you to know, so there's a lot to be covered here, class. All right. All right, again, let's quickly recap what we've done. Basics of trigonometry, unit circle, fundamental identities, sinusoidal functions and their graphs, the rest of the trigonometric functions, tangent, cotangent, secant, and cosecant and their graphs, phase shift and curve fitting was discussed. Now we're going to go to inverse functions. And to do that, first, let's quickly refresh everyone's memory about inverse functions and the meaning of that and the effect of dealing with them. As you know, a function has an inverse if it's 1-to-1. Otherwise, it doesn't. However, sometimes you can restrict it such that it becomes one-to-one. Domain of one becomes range of the other. Range of one becomes the domain of the other. They are symmetric with respect to the line y equals x, okay? And that's all there is to it. There are a lot of properties that you should be comfortable with. If I give you a pair on the graph of the function f of x, you should be able to come up with the corresponding pair on the graph of the function f inverse of x. So let's go to trigonometric functions. None of the trigonometric functions is one-to-one, and none of them has an inverse, just the way they are. Because of that, you have to restrict the domain so it becomes one-to-one. If you look at a sine function, it's a periodic function, it fails the horizontal line test, it is not a one-to-one function. So we cut it such that it is between negative pi over 2 and pi over 2. First of all, the domain is all real numbers. It's not a one-to-one function. The range is from negative 1 to 1. Okay, everybody, that's something everybody knows. It's important that you know that about the sine. It is not a one-to-one function. It doesn't have an inverse. However, the blue piece makes it one-to-one. I want to make sure everybody understands what's going on here and the restriction, and why the restriction from negative pi over 2 to pi over 2. Understand, we want a one-to-one function, and we want all the range to be covered, and we are hoping we pick a piece that is a continuous piece. Understand, let me use a different color and make a point. It could have been that if we pick this portion, look at this, if we pick this portion of sine and this portion of the sine, they will cover the whole range from negative 1 to 1. And mathematicians decided that's a good idea. They wanted to be a continuous function, so they didn't pick this part. Are you with me? Instead, they picked from negative pi over 2 to pi over 2, and that becomes a one-to-one function, and it's a continuous function. Now, how do you graph its inverse? Let's look at just a few easy pairs. Look at this one, class. Negative pi over 2, negative 1. Zero, zero. Pi over 2, 1. All you have to do, graph at those 3 points. Corresponding to negative pi over 2 comma negative 1, we have now this point, okay? So this is still the sine function, but it is the one that is one-to-one and has an inverse. Okay, class? 0, 0 is there, pi over 2 is there, so all of them are there. Now, let's go with the inverse. To go with the inverse, what happens to this pair? This changes to negative 1 comma negative pi over 2. 0, 0, it remains the same, it's 0, 0. But about pi over 2 comma 1 changes to 1 comma pi over 2. So all you have to do, really draw those 3 points, and you have a rough sketch of the inverse function. For the inverse, the domain and range are interchanged. The pairs are interchanged, and here's the graph, everybody. Do we see that? Is there any questions? So there's a very simple process that leads to the graph of the inverse class. What is that process? Use the same pairs on sine y equals sine x, interchange x and y, you make up the new pairs and you graph it. Now, when they are graphed together, class, the graph of y equals sine x in red and the graph of y equals sine inverse in blue we got the general shape. Now it's extremely important to understand the domain and range are interchanged. Therefore, when y equals sine inverse of x, first of all, by definition, it means x equals sine y, okay? And it is x now that can be between -1 and 1, and y is between -π/2 and π/2. I hope it's clear. Let's look at some basic examples to get us started. We are interested in sine inverse of 1. First and foremost, it is important to understand we are looking at an arc or an angle. So the way I approach it is very simple. What is sine inverse of 1? I don't know. Let's say it's theta. Therefore, by definition, sine theta must be 1. And you know the answer is π/2. Now, it's important to distinguish between the equation that you're looking at and the sine inverse. Class, later on we solve this equation. This equation has infinitely many answers, okay? But when we are looking at sine inverse 1, then we are restricted to this, okay? And we got to pay attention. Anything outside is unacceptable. Here's the next one. What is sine inverse of 1/2? I don't know. Let's call it alpha, beta, theta, anything you want, or A. By definition of sine inverse, that means sine theta must be 1/2. Again, I'm assuming everybody remembers all the common arcs. You really can't afford not to, okay, class? And I promise you, if you don't remember them, you're gonna have a difficult time with the next course. So you should know all the common arcs and all the trigonometric functions of common arcs. In this case, theta is π/6, and you're done. Okay, the next question, actually, the animation is not in a proper order. So I'm going to put it here, part B. So let me just go there. Sine inverse of -1/2. We assume we don't know that. We call it alpha, beta, gamma, theta, you choose. So by definition, sine theta becomes -1/2. And again, it's a common arc. You should know the answer is -π/6. Sounds good, class? Any questions?
No.
Perfect. Now, this was the question I used. So if you are given situation when you're not dealing with a common arc, you really have to use a calculator. And it's very simple. Everybody knows on a calculator, you can use the sine inverse, cosine inverse. All you have to do, click on second sine or second cosine. I'm assuming everybody knows that. You can look at your calculators. So these are not common arcs. And so I have no idea what the answers are. Because I don't know, I'm not going to set it up equal to theta and solve it. Just as an example, the first one equals theta, that means sine theta is 1/3. I don't know the answer, it's not a common arc. So basically you put it into a calculator and it gives you the answer. That's all I can tell you. The only thing you want to be careful, the mode has to be the way it's given. It should be in radian mode, everybody. Radian mode. Unless, you know, otherwise it's mentioned. Unless it says, you know, in what is the answer in degrees. You find it and then you change it to degrees, okay? All right. What about something like this? Sine of sine inverse of 0.5. Okay, that's what we want to discuss, okay? And so can anybody tell us what's the answer here, class? And why? Okay. If you have two inverse functions, their composite function is x, as long as it is an acceptable one. Do you follow what I'm saying? And that's important to pay attention to. So, is 0.5 within the domain of sine inverse and range of sine? The answer is yes, so the answer is 0.5 and you're done. Okay, class? Let's actually do this. Oh boy, just erase this. F O F inverse equals F inverse OF equals X. So that one is 0.5, but what is this one? Well, sine inverse has a domain between -1 and 1. In other words, you all remember, sine has a range of -1 to 1. Sine inverse has a domain of -1 to 1. If I have a number beyond number 1 or smaller than -1, it doesn't work. So if you change that to 2.8 or 1.1 or -2.1, doesn't have an answer because it's not within the domain of sine inverse or the range of sine. Is everybody following that? Is there any questions, class? We are in good shape?
Yes.
Everybody?
So if it's greater than 1, then it's undefined.
Yeah, let's say it was 1.1, anything larger than 1,
Yeah,
because it
greater
can
than
only
1.
go, yeah. Okay.
Oh,
Does that
okay.
make sense?
Yes, it does. Oh, yeah, it's in the bottom. Sorry.
Sure. So everybody is fine with that. Okay. So, however, It's important that we see it. If it's the other way around, in other words, if you have sine inverse of sine, it could have an answer, and we'll look at it as we come across it. I'll show you, okay? So that could be slightly different. So we don't want to, mix them up. So again, we'll see as we come across. All right. So again, the synopsis of what was discussed, if you're looking at inverse functions, it works if it's within the acceptable range or domain accordingly, okay? So let's look at this case and see what's going on for the first one, okay? Now again, when you're looking at sine inverse of sine, things are different. I want you to know that things are definitely different, okay? And I'll tell you what I mean by that. They will, most of the time, okay, unless it's something crazy, most of the time they do have an answer. And that's important to pay attention to because it is different, as I mentioned, okay? So in what sense is it different? Let's find out. The first one says sine inverse of sine pi over 8. If pi over 8 is within the domain of sine, and you know sine goes from negative to positive pi over 2. That works, and you're done. Okay? That's simple. However, what about 5 pi over 8? Can I say the sine inverse of sine 5 pi over 8 equals 5 pi over 8? And the answer is no, because this is not in this range, is it? By the way, class, how you know that? Remember, 4 pi over 8 is the same as pi over 2, so 5 pi over 8 is larger and it's out. So how do you handle that when that happens? Okay. Then this does have an answer. This does have an answer because sine of 5 pi over 8 has an answer. Okay. So you have two choices. If it's a common arc, you can find that and then evaluate the sine inverse. But if it's not common arc, there is a way around it, and that's very simple. First, recognize what's going on, whether this is positive or negative, and then take it from there, okay? Now, as you know, sine is positive in the first quadrant and the second quadrant, okay? So sine of 5 pi over 8 is positive, and sine of 5 pi over 8 is the same as sine of 3 pi over 8. You have to find an angle in the interval. 5 pi, by the way, this means, I hope everybody remembers, this means not an element of, it is not an element, it's not in between. And because it's not in between, take a look at the graph, okay? Sine is positive in the first and the second quadrant because sine corresponds to the y coordinate. Everybody remembers that, right? And so sine of 5 pi over 8 is the same as sine of 3 pi over 8. I want you to see that the reference arc is 3 pi over 8, everybody. And when I was discussing the reference arc, the trigonometric functions become the same as the trigonometric functions of the reference arc. You have to figure out positive or negative. In this case, it's positive. Okay, so it's the same as 3 pi over 8. The answer is 3 pi over 8. I hope everybody is following what happened here. And again, as we look at more and more examples, this thing becomes easier. Okay, class? All right, we have time to look at cosine also, class, and we're going to take it from there. Is there any question? Is everybody okay with that? All right. Cosine, it's not a one-to-one function. Same as sine. Okay, why is that? It's a periodic function. It fails the horizontal line test. So what do? You restrict the domain. How do you restrict it? Well, we restrict it from 0 to pi. Why 0 to pi? Because we want it to become one piece, a continuous function. Okay, so I hope everybody understands what's going on here. The way we do sine is different than cosine. The way we do the restriction on sine and cosine. Sine goes from negative pi over 2 to pi over 2. Cosine goes from 0 to pi. In fact, all the functions we have studied, they follow either or class. Okay, they either follow sine or cosine. For example, tangent follows sine. Cotangent follows cosine. Okay. Secant. Secant is what? 1 over cosine, so it follows cosine. Cosecant is 1 over sine, so it follows sine. As far as the restriction. Okay, class? Yeah, I hope everybody's comfortable with the concept here. All right. So, having said that, let's see what happens next. Now that we have the restriction, look at this pair. 0, 1 becomes 1, 0. Right? Pi over 2, 0. I better not write the rest of it, Just, you don't have to write them, but you get the 0, 1 becomes 1, 0. Pi over 2, 0 becomes 0, pi over 2. Pi negative 1 becomes negative 1 pi. And we have the inverse. So we have the inverse. Domain was 0 to pi. Domain. It's the range now. Okay. Range was negative 1 to 1 becomes the domain. Now that's the same as sine. And those are the pairs as I mentioned. And if you graph it looks like this, and as you can see, it's symmetric with respect to the line y equals x. It's a very straightforward class question, okay, concept. If we learned sine, this goes fairly fast, nice and easy. So before we take a few minutes of break, I want to quickly look at a few examples to make some sense out of this. Okay, class? Remember, for sine, we go from negative pi over 2 to pi over 2. For cosine, from 0 to pi. Okay? Why is that? We like to have a continuous function, and we like to cover everything in the range for cosine as well. So here's a simple example. I'm going to start with the first one. You can ignore all of them. Look at the first one. What is cosine inverse of 0? We don't know. Let's say it's theta. What does it mean? Cosine theta is 0. So what is theta? Pi over 2. I hope you remember that. Cosine inverse of 1/2. What's the answer? We don't know. Let's say it's theta. So cosine theta must be 1/2. That's a common R. Pi over 3. Again, you're not looking at an equation, you're not looking at the equation, you're looking at inverse function, therefore it has a unique solution, not infinitely many. That's important to distinguish between the two. So what is cosine inverse of negative 1/2? I don't know, let's call it theta. By definition, cosine becomes negative 1/2. Now, As far as 1/2 is concerned, is pi over 3. That means the reference arc is pi over 3, because remember, you can look at the positive portion and say that's the reference arc, pi over 3. Okay? But remember, cosine goes from 0 to pi. In the second quadrant, cosine is negative. Why is that? Cosine is the same as x coordinate. So now, what is the answer? Pi minus pi over 3. Because pi over 3 is the reference arc, so the answer is 2 pi over 3. What is cosine inverse of negative square root of 2 over 2? We set it equal to theta, and we say cosine theta is that. So let's discuss the positive square root of 2 over 2. Cosine theta is equal to square root of 2 over 2, and theta is pi over 4. This is negative. It takes us to second quadrant. Pi minus pi over 4 is the answer. Sounds good, class?
Yeah.
All right, class. So let's see. Just, sorry, I want to hide this. I think I did. All right, so we're looking at the next set of examples, so hopefully we get a chance to catch up. As you can see, cosine of 5 pi over 6, because we decided for cosine we go from 0 to pi, we are in good shape, and we're done. That's all there is to it. Everybody can see that? 5 pi over 6 is in between 0 and pi. What is the answer to part B? Can anybody tell us the answer to part B? Okay, class? The answer to part B is fine, 0.2. You're looking at the inverse function. Inverse is between -1 and 1. We are okay, so it's 0.2. They undo each other. And that's something you want to pay attention to. Do they undo each other or not? And when? So, what about 5 pi over 4? Does that work, class? Is 5 pi over 4 between 0 and pi?
Yes.
No,
No.
because
Not.
class, 4 pi over 4 is the same as pi. So it's not, the answer is not 5 pi over 4. However, it's not that it doesn't have an answer. 5 pi over 4 is not.
It's 3/4, isn't it?
It's 3 pi over 4. Why is that? I want to make sure everybody understands why this is the case. Okay. So we are looking at cosine of 5 pi over 4. Cosine is positive in the first and fourth quadrant, and it's negative in the second and third quadrant. This is the third quadrant, 5 pi over 4. Therefore, we want to go with the with the second quadrant, 3 pi over 4. Okay, I want to make sure everybody understands what's going on. And that's why we replace it with 3 pi over 4. So you have to pay attention to this sign of the trigonometric function. Is it positive or is it negative? So cosine of 5 pi over 4 is negative because it's in the third quadrant. So you have to choose the quadrant accordingly. And in both cases, whether it's quadrant 1 or 2, notice that pi over 4 is the reference arc. So what is the difference between C and D, and what is the answer to part D? Can anybody tell us? What is the answer to part D? What happens as far as part D is concerned? Anyone?
Is there not a 2 cosine? So it's undefinable, or D and E?
Very good. You're done. 2 is out.
Better than 1.
Because you're looking at cosine inverse class. You're looking at cosine inverse, okay? And it can only go from -1 to 1, and that's why it's out. Does that work? Is there any question?
It's only 1 and 1.
Between -1 and 1.
Yeah, between -1 and 1.
And 2 is not in that range. Okay? All right. I'm going to move on. I hope everybody is okay with this. Any questions? Class, are we ready?
Yes.
Yes.
All right. So what about other functions? Let's quickly discuss those also and see how that works. For example, what about tangent? As you know, tangent, like sine and cosine, is not a one-to-one function. So we limited just the way we did with sine, negative power 2 to power 2. The difference is negative power 2 and power 2 are not included, remember, because we have vertical asymptotes at those points. And so here's the tangent, not a one-to-one function, and here's an inverse. Okay, in order to come up with the inverse, we limit it to what you see. And now it has an inverse. So y equals tan inverse of x, by definition means x equals tan y. Because, let me use a pen here. The domain is this. That would be the range. The range is negative to positive infinity, and that becomes the domain for the inverse function. So a couple of easy numbers, just as an example class, this is 0, 0, it remains. Another point that everybody knows is pi over 4, 1, becomes 1 pi over 4. Negative pi over 4, -1 becomes -1, negative pi over 4. And you can graph those pairs, and the graph looks like what you see. Now, one thing I want you to pay attention to is the following. The graph of tangent function has vertical asymptotes. This one has horizontal asymptotes. Okay, class? In the case of a y equals tan x, x equals pi over 2 and x equals minus pi over 2 are the vertical asymptotes. In the case of a tan inverse, y equals pi over 2 and y equals negative pi over 2 is the vertical asymptote. Okay, so it's really not that big of a deal, but you should make the transformation. That should be very straightforward. Okay, class? So we are going to make that connection and we move on. Any questions before we do so? Okay. No. All right. Let's go to the next page, class. And answer some questions. This is just basic as before, okay? Tan inverse of 1, just quickly, I'm going to write one of them, then I'm going to give you a couple of minutes to do the rest. Tan inverse of 1, I don't know the answer. Let's say call it theta. By definition, tan theta is 1. theta must be pi over 4. So what I'm going to do, I'm going to give you a minute, okay, to figure this out on your own. It shouldn't be a big. All right, so what is the answer? Let's say it's theta. By definition, tan theta is negative square root of 3, and that's square root of 3 is pi over 3. Negative makes it negative pi over 3. The next one, the same thing, theta. So tan theta is square root of 3 over 3, and that's pi over 6, a very simple common arc. And the last one is the same thing, negative, because remember, tangent goes from negative pi over 2 to pi over 2. So those are very straightforward. I can't imagine you guys having difficulty with that, okay? Everybody is fine with that? Any questions?
No.
All right. I want to go to the next page. All right, so here's the next one. Okay, so that's not in the order that I was hoping. Well, it is what it is. Let's deal with it. I'm sorry, class. So let's just go with the first one at least. You know, it is doable. The other one, you can see the answer. I was hoping it's not like that, but that's okay. All right. So the very first one now we are looking at cosine. Okay. And so what's happening is 2 cosine inverse of x equals pi over 2. You have to get to cosine inverse, we divide by 2. Now by definition, x is cosine of pi over 4, and we know it's square root of 2 over 2. All right. Is everybody okay with that? Is there any questions? The next one, class, you have to divide by 3. So let me just, so right, first and foremost, you divide by 3. When you do that, you get sine inverse equals pi over 6. So by definition, x is sine pi over 6. And we know the answer is 1/2. That's a very simple process. Now the next one, we divide by 3 again. By the way, class, this was the equation. You have to move things around. That means this is moving that way. This is moving that way. And now we get to this equation. I hope you see that there is a step missing. So first, the question that we need to see. The question is 5 sine inverse x minus 2 pi equals 2 sine inverse x minus 3 pi. We bring all the sine inverses together. 5 minus 2 becomes 3 sine inverse x. Negative 2 pi moves to the right, becomes positive 2 pi. With negative 3 pi is negative pi. Divided by 3, you get negative pi over 3. So x must be sine of negative pi over 3. And we know that pi over 3 gives us square root of 3 over 2. So this is negative square root of 3 over 2. Okay, class? Sorry, the order was messed up, so we couldn't do the job the way I liked it. So in any event, that's part of technology. So we're going to go to the next one. I'm hoping we are okay with this class. Everybody's fine with that. Any questions before we move on? Okay. Okay. Now here's what we have. F of x is 2 sine x minus 1. And x is between negative pi over 2 and pi over 2. Okay. So we want to find f inverse. And the reason it's given that x is between negative pi over 2 and pi over 2, so it does have an inverse. Remember, sine in any form or shape doesn't have an inverse unless you restrict its domain, and that's why we've done that. So I want to show you the process of finding the inverse as we've done it before. Okay. So in order to make life easier, first we give it the name y instead of f of x. Everybody remembers that? Okay. So that's the first thing I want you to pay attention to. We interchange x and y. Everybody remembers that? We interchange x and y. And now we solve for y. How do we do that? We move the negative 1, becomes positive 1, so x plus 1, we divide by 2. So we interchanged x and y, and we solve for y. So what do we call it now? F inverse. Okay. So y is sine inverse. So f inverse of x or sine inverse of x plus 1 over 2. Let's discuss the domain and range. Let's discuss the domain and range class. Let's see what is given. As you can see, the domain of f of x is given. So that must be the range of f inverse. Is everybody okay with that? The domain of f of x is given. That must be the range of f inverse. Okay. Now, to find the other two, there are two ways, and I'm going to look at both ways, and you figure out which one is easier for you. You do the method that works out for you the best. You don't have to do it both ways, okay, class? But I want to show you both ways. We found the sine inverse. And what's going on with the sine inverse? The domain of sine inverse is negative 1 to 1. That means the argument of sine must be between negative 1, and we're going to solve for x. So how do we do that? We multiply by 2. We subtract 1 from all sides. X is between negative 3 and 1. So what is this? Domain of f inverse, which is the same as range of f. And we're done. But some people may find the next method that I'm going to go over easier. So let's see if this is the case or not. Okay, so let's do that. Here is the second method. Y is equal to f of x or y equals 2 sine x minus 1. So sine x is y plus 1 divided by 2. We know that sine must be between -1 and 1. Therefore, y plus 1 over 2 must be between -1 and 1. I hope you see what's happening. Sine is found to be y plus 1 divided by 2, and sine is between -1 and 1. Now you can solve for y, which means you're going to multiply by 2, and you're going to subtract 1, and you get to the same answer. Now, which one is easier to follow? I have no idea. You decide which one works best for you. Okay, class? We're going to go over the next question. And the last one for this section, okay? All right, we have a similar question I want to look at. I hope everybody is doing okay. Now we want to find the inverse function for this case, okay? And x is given between -2/3 and -2/3 plus power 3, okay? So first let's find the inverse function by calling f of x y. The next step is to interchange x and y. So the next step is to interchange x and y. Divide by 2, cosine inverse of x over 2 is 3y plus 2. Move the 2 to the other side and subtract. Divide by 3. So you get 1/3 of cosine inverse of x over 2 minus 2/3. It's a very straightforward process, class. Okay, I hope you find it very straightforward. Okay. So what we want to do is to find the domain and range. So we're going to use the given. What is given? The domain of f of x. If this is the domain of f of x, it better be the range of f inverse. Right? So let us look at
Plus,
domain of, yes. Everybody okay with that, right?
yes.
Now, the domain of f inverse is between -1 and 1. And it's important to know what we mean by that. This is the portion that you look at, cosine of this, and then x over 2. So x over 2 is between -1 and 1. X must be between -2 and 2. If this is the domain of f inverse, it must be the range of f. And you're done, but again, let's quickly look at the second method, okay? So y or f of x or 2 cosine 3x plus 2 must be between -1 and 1. Okay. So when you multiply it by 2, if the cosine is between -1 and 1, then 2 times that must be between -2 and 2. Okay. Sine and cosine between -1 and 1. 2 times that between -2 and 2. Okay, we're going to go to the next section. I'm hoping that we can get some time with that one. So at least we've covered what we were supposed to tonight, because we got slowed down last time and even tonight. But let's see if we can continue on the function, on the concept of inverse functions. Okay, class, so let's do that. So this is 7.2. We are just going to do more of the same thing, everybody. We are going to do more of the same thing, and we're going to make it a little bit more interesting. That's the idea, okay? So this is the recap of what we have seen, okay? Let me just start this in this format, and let's just get rid of this one. So, okay, so it's easy to read it. We are interested in sine of tan inverse of 1/2, and again, we don't know what the answer is, so we're going to take our time. What is tan inverse of 1/2? We have no idea. We give it a name theta. By definition, tan theta is 1/2. Okay, so what we want is sine of theta, and tan theta is 1/2, which is positive. Okay, and because tangent, remember the restriction is between -power 2 to power 2, then 1/2, which is positive, gives us quadrant 1. Is everybody okay with this so far? So what is it that we want to calculate? We want to calculate sine of theta given tangent equals 1/2. Sine of theta given tangent is equal to 1/2. Okay. So To do that, we can go with the easy way out. Okay, you remember that x squared plus y squared equals r squared, or equals 1 squared, depends upon what you have. In this case, if you go with that, remember tangent is what? Sine over cosine or y over x. Do you remember that? So if sine is y over, if tangent is y over x, we can say 1/2. So y must be 1, x must be 2. And when we do the drawing, x squared plus y squared equals r squared, we end up with 5 for r. We are using one of the methodologies we learned before. Sounds good? Is everybody okay with that? So if we go this route, what is sine theta? Sine theta is y over r. Remember that? Sine theta is y over r. And we're done. By the way, things in blue and red or purple on the right side is just the repetition of things we've seen to refresh your memory about inverse functions. So we're going to continue on these thoughts and look at a couple more examples. Is there any questions? Is everybody okay with this so far? All right. Again, by any chance, if we were dealing with a common arc, we wouldn't have to go this route. We could easily figure it out. But if it's not a common arc, we can go this route. So let's look at the next example. Cosine of sine inverse of negative 1/3. Again, we are looking at cases that are not necessarily common arc. Okay. So if sine inverse of negative 1/3 is missing, and we call that theta, that means we are looking for cosine theta, class. We are looking for cosine theta. That's what we are looking for. And so this means sine theta must be negative 1/3. Now, when sine is negative, okay, and remember, theta is between negative pi over 2 and pi over 2. Why? Because of the limitation of sine inverse. Okay, limitation of sine inverse. So with that being the case, because it's negative, we are dealing with the fourth quadrant. We said sine is y over r. Okay. So negative 1/3. That means y must be negative 1, r must be 3, x must be missing. X squared plus y squared equals r squared. We have y, we have r, we can find the missing x. I hope everybody can see why this is the case. Everybody can calculate that, right? Because x squared plus y squared, negative 1 quantity squared is 1, is equal to 9, x squared equals 8, and x is square root of 8 or 2 square root of 2. And practically we are done. By the way, if you want to look at this also, this is another approach. If you want to approach it from the right triangle point of view, you can do that as long as you do it carefully. Okay, class? Sounds good. Any questions? All right. Here's the next one, everybody. Now, this is a question, I think, with the fact that we looked at a couple of examples, you should be able to come up. The only thing that I'm going to put up for you, what is cosine inverse? We have no idea with the name theta. Okay. And so we are looking for tan theta. So I'm giving everybody a minute, see if you can figure this out, class. All right. So cosine theta is -1/3. Remember the relationship as far as cosine is concerned. To make it 1-to-1, we choose 0 to pi. Okay. And so, so cosine is negative from 0 to pi in the second quadrant. Okay. And cosine is x over r. So x is -1, r is 3. X squared plus y squared equals r squared, same as before, will give us the same 2 square root of 2 we had before. Okay, class, x squared plus y, this is the same as far as finding the missing side. And so this is another approach, class. If you want to approach it from the point of view of a right triangle, you can, okay? What you need to know, the hypotenuse is given as 3, one side is 1, find the missing side, okay? And that's just as good if you want to go that route, okay? And so you want tan of theta, and you find it, you end up with 2 square root of 2 over -1, which is -2 square root of 2. Now, what is important is to pay attention to the sign, okay? So you want to make sure that you're okay with that. Remember, in the second quadrant, cosine is negative, so is tangent. That's why you got to come up with the proper sign. Proper sign, everybody. Sounds good? Everybody okay with that?
Yes.
Yeah. So we're just
Excellent.
gonna pay attention to the signs, right?
Yeah, here's the deal.
Okay.
If you remember the quadrants and how they
Mhm.
work,
Yeah, I do.
you before even you come up with the answer, you should know the sign. Again, just
Yeah.
going back to the whole thing, we decided cosine inverse of negative means quadrant 2. In quadrant 2, what's going on? The only thing that is positive is sine.
Yeah.
Everything else is negative. And by the way, when sine is positive, so is cosecant, of course. Okay. All right. So here's the next one. What about the secant inverse? Okay. Now remember what is secant. Secant is the same as 1 over cosine. So the way we handle it, and by the way, I want you to pay attention to this because it really depends on the text. In some texts, they don't go with this restriction. They have a different restriction on that. And I want you to know that this is actually, in my opinion, a better restriction. Okay. But some have a different take on that. To me, secant goes with cosine. So if the restriction on cosine is 0 to pi, so is the restriction on secant. So again, if you see a slightly different take on that from a different text, don't worry about it too much. Needless to say, secant means 1 over cosine, and it's not defined at pi over 2. We should know that. When we look at cosecant, cosecant is over sine, so it goes with sine. Sine goes from negative pi over 2 to pi over 2, so does cosecant, okay? And of course, at 0, it's undefined because, or it's vertical asymptote, is simply because cosecant is 1 over sine, okay? So, in other words, if I use a different color here, okay, so here's the sine. Okay, here's the restriction on the sine. Okay, so here's the portion corresponding to cosecant. Okay, just as an example. As far as cotangent is concerned, also cotangent follows cosine. Okay, and it's easy to see that. Just remember, one complete cycle goes from 0 to pi. Do you remember that? So that's easy to remember. All right. Now, let's look at some examples. So at the top, we have the synopsis of what we just discussed: secant, cosecant, and cotangent inverse. So for example, what is cosecant inverse 2? Okay, that means, okay, I have no idea what the answer is. I'm going to call it alpha, beta, gamma, theta, you name it. And so by definition, cosecant theta must be 2. I don't know the answer, but I can go with sine. Remember, cosecant is 1 over sine. So 1 over sine is 2. That means sine is 1/2. And that I answer. Sine equals 1/2 when theta is pi over 6. Does that make sense? Is everybody okay with that?
Yeah.
Excellent. I'm going to move on. So when we have a common arc, it makes it easier. So again, when I'm looking at cosecant or secant, I immediately go to sine and cosine. Cotangent, you don't have to, okay? You don't want to go from cotangent to tangent. And here's the reason. Tangent goes from negative pi over 2 to pi over 2. But cotangent goes from 0 to pi, so we can easily make a mistake. So be careful with that. So you have to figure out the cotangent on itself if it happened to be a common arc. If it's not, it's a different story. So let's look at these examples and see how we deal with that. Let's start with the very first one. Secant inverse 3 it's the same as cosine inverse 1/3. Is everybody following what happened here? You can say this is theta. That means secant theta is 3. That means cosine theta is 1/3. Now, why is it that we didn't do that? We kept it at cosine inverse equals 1/3 because it's not a common arc. So you just plug in cosine inverse 1/3, okay, using a calculator, secant cosine 1/3, and it gives you the answer. It's in radians. Is everybody following that, class? If it's not a common arc, you have to keep it as an inverse. So this is how you do that. Oh, okay. Part B, cosecant inverse of -4. Again, it's not a common arc by definition. If you set equal to theta, that means cosecant theta is -4. So cosecant and sine are reciprocal of each other. You can write sine inverse of -1/4, everybody. I apologize. This is wrong, class. So -4. Everybody got that?
Okay. Thank
The
you.
reciprocal of -4 is -1/4. Now you use a calculator. By the way, they're asking for 2 decimals or however many. By the way, if they don't ask you for 2 decimals, you really go at least with 4, at least, if not more, okay? So I want everybody to know that. So with that being the case, here's the next one. Cotangent inverse of 1/2. We don't have a key for that. There are 2 ways to do that. Because with cotangent goes cosine, you really have to figure out the cosine class. That's the best course of action. I'm going to discuss the tangent in a moment. Okay? And as long as you have cotangent, okay, you can figure out cosine as follows. Okay? I want you to see this picture. Okay? X squared plus y squared is 5. Okay? Cotangent is x over y. Cotangent is 1/2. So x is 1, y is 2, and r is 5. R squared. And so r is square root of 5. Okay. And so with that being the case, cosine inverse of 1 over square root of 5. So I hope everybody can see why that. Okay. It's 1.1. Now, before we move on, there is another method, and it's actually a tad more complicated. I want you to know that. So if we know it's a positive x, we can use tan inverse of 1 over x. Why is that? Because if it belongs to the first quadrant, tangent and cotangent in the first quadrant are both positive, and that works out. So it doesn't matter when x is positive, you can use the tan inverse. But if it's not, you can't use the tan inverse of 1 over x, but you have to add pi simply because of the limitation on cotangent going from 0 to pi. So the best course of action is to go with the cosine inverse class. So figure out the cosine inverse from cotangent inverse and look it up from your calculator. Okay. So if you look at the next one, cotangent inverse of -2, and again, cotangent is x over y. You can say x is -2 and y is 1. And you come up with the same 5 again, class. Look at this graph as far as r squared is concerned. But this time, -2 over square root of 5. And if you look that up, that means second cosine -2 over square root of 5. That's how you look it up by using your calculator. You come up with the answer. Is everybody okay with this? Is this making sense to everyone?
Kind of, but I feel like the homework is gonna really.
Yeah, the homework is going to help, but I'm going to recap this page. I want to make sure everybody understands what's going on here, and that is very simple. What if we don't have a common arc and we want to evaluate this? From secant, we go to cosine, the reciprocal. From cosecant, we go to sine, the reciprocal. but we cannot do it with cotangent. Why not? Because tangent and cotangent, they use different restrictions. Tangent goes from negative power 2 to power 2. Cotangent goes from 0 to pi. Because cotangent goes from 0 to pi and so does cosine, the best course of action is to figure out what is the cosine value given the cotangent. Okay, class? However, if you want to go with tangent, it really depends on the value of x. If cotangent is positive, you can go with simply the reciprocal for tangent. But if it's not, you go with the reciprocal, and whatever the answer is, you have to add pi. Okay? And why is that? I want to make sure everybody understands. If you're looking at tangent inverse is negative, it's going to be in the fourth quadrant class. Okay, remember, the inverse function for tangent gives you a negative value, gives you the fourth quadrant. So to bring it to the second quadrant, you need to add pi. Okay, that's why. All right. So here's the next one we want to look at. We want to write the trigonometric expression when we are interested in finding sine of tan inverse of u, knowing that tan inverse of u represents something such as theta. That means tan theta is u and sine theta is missing. So first thing first, understand this. What is tan inverse? I don't know, alpha, beta, gamma, theta, you choose. What does it mean? The inverse definition tells us tan theta must be u. Therefore, sine theta is what we are interested in. So how do we go from tangent to sine? Okay. There are a couple of different ways. We're going to quickly look at it from the point of view of identities. Okay. And then if we want to discuss the second method. The identities, we know that sine is the same as 1 over cosecant, and cosecant has a relationship with cotangent, and that means 1 plus cotangent squared is cosecant squared. We know that. Okay, class? Is everybody okay with that so far? So 1 plus cotangent. Cotangent is 1 over u, squared is 1 over u squared. It's cosecant. You take common denominator, you get u squared plus 1 over u squared. This is cosecant squared, class. This is cosecant squared. What is sine squared? The reciprocal of that. The reciprocal of that. So what is theta? Plus minus the square root. The u squared comes out as u, and we choose only the positive. Why is that? Because sine and tangent go from negative power 2 to power 2, both of them. Therefore, they both have the same sign. If tangent is negative, so is sine. If tangent is positive, so is sine. So that takes care of the business. Okay? The other method, if it's helpful. Tan theta, what is tan theta, everybody? Tan theta is y over x, isn't it? What is sine theta? Y over r. So what is tan theta? U. Okay. There's another method. Is everybody paying attention? I want to show you a different method. U. So I'm going to get U over 1. So I hope you see y. I'm going to put U over 1. So I'm going to claim y is U. And x is 1. If x squared plus y squared is r squared, then u squared, x squared is 1 squared, y squared is u squared. 1 squared plus u squared equals r squared, and r is simply 1 plus u squared. So now you put it as y over r, y is u over 1 plus squared, and that gives you exactly the same answer. And which one is easier? I have no idea, class. You make a decision. Okay? Is there any questions, class, so far? All right. What I'm going to do, class, I'm going to show you the next page. We're not going to go over that because I like you to spend a few minutes and next week. The reason I want to do this page next week because I want to refresh your memory about what we did today. And it is important that you spend some time on this so next week we can move on fairly fast. Sounds good, everybody?
Okay.